How to diagnose RC, motor cogging and rough startup issues. Have you ever noticed your remote-controlled vehicle hesitating or stuttering when you start it up? This is often a sign of motor cogging or rough startup issues. Understanding how to diagnose these problems can keep your RC toys running smoothly. Let's break it down step by step. First, pay attention to how the motor behaves during startup. If you see jerky movements or hear rattling sounds, that is a clear indication of cogging. This can happen when the motor struggles to reach a steady rotation. One of the first things to check is the electronic speed controller settings. Incorrect timing settings can lead to misfires and hesitation. Make sure the timing settings align with the specifications of your motor to help reduce cogging. Next, inspect the electrical connections. Loose or corroded wires can interrupt power delivery, causing rough startups. Ensure that all connections between the motor and the electronic speed controller are secure and clean. Another important factor is the type of motor you are using. Sensorless brushless motors depend on the electronic speed controller to estimate rotor position. This can lead to startup hesitation. On the other hand, sensored motors use sensors for rotor position detection and usually start more smoothly. If you have a sensorless motor that is cogging, this could be the reason. Don't forget to test the voltage supply. A low battery can reduce torque output, making it hard for the motor to start smoothly. Always check that your battery is fully charged and can deliver enough power under load. Mechanical components also play a role. Check for binding or misalignment in the drivetrain or motor bearings. Manually rotate the motor shaft to feel for any resistance. Inspect gears for wear or damage, which can also contribute to cogging. Recalibrating the electronic speed controller can help improve synchronization between the motor and the controller. This step can often reduce startup stutter. Another aspect to consider is the size of the pinion gear. If it is too large or too small, it can affect motor load and worsen cogging. Adjusting the pinion gear to match the motor's specifications can help achieve a smoother startup. Finally, consider the pulse width modulation frequency settings. The frequency sent by the electronic speed controller can impact how smoothly the motor operates. Experimenting with higher frequencies may reduce cogging at low speeds. Extreme temperatures can also affect motor performance. High or low temperatures can change magnetic properties and efficiency, leading to increased cogging. Additionally, lower quality motors may have construction flaws that cause rough startups. By following these steps, you can effectively diagnose and address cogging and rough startup issues in your remote-controlled motors. Regular maintenance and calibration are key to keeping your RC vehicles performing at their best.